Good day, viewers. This is Ademola Johnson, your scientist, your chemist, your biologist. I want to thank you for your views, and I also want to encourage you to click on subscription and subscribe and like this video and share it. Don't forget our physical lectures for post-UME, for JAM, for WAEC, for NECO. Nursing entrance has started in kilometer 8 Saple Road, Benin City, in Christ the Rock Academy. So now today we want to look at oligosaccharides. We have been looking at series of carbohydrates. So we just concluded monosaccharides and we are going to oligosaccharide. Oligosaccharide. So this is unlike elementary biology. They will say carbohydrate is divided into monosaccharide, disaccharide, and polysaccharide. Yes, it is true, but it's supposed to be that it's divided into monosaccharide, oligosaccharide, and polysaccharide. So because the first member of oligosaccharide is a disaccharide. Now, what is oligosaccharide? Now, this is a carbohydrate complex sugar consisting of a number of simple sugar residues ranging from 2 to 10, which are already condensed together. What am I trying to say? Oligosaccharide is a carbohydrate. It's also known as complex sugar. It consists between 2 to 10 carbon atoms. 2 to 10 simple sugars, exo sugars, connected together, condensed together. You know, when condensation takes place, we have explained that water molecule will leave. Now, there are 9 types. There are 9 types of oligosaccharide. What are they? These are 1. Disaccharide. 2. Trisaccharide. 3. Tetrasaccharide. 4. Pentasaccharide. 5. Hexasaccharide. 6. Heptasaccharide. 7. Octasaccharide. 8. Nonasaccharide. And the last one, 10. Decasaccharide. So now, the one that is most important now is what? Disaccharide. Before we talk about disaccharide, let me talk generally on the remaining ones. Di means what? Di means 2. So a disaccharide is a biomolecule that contains 2 simple sugars joined together with the elimination of water molecule. Then trisaccharide has 3 simple sugars joined together with the elimination of water molecule. Tetrasaccharide contains 4 simple sugars joined together with the elimination of water molecule. Pentasaccharide is a biomolecule that contains what? 5 simple sugars, sugar residues condensed together. So we want to dwell more on this one. Now, this is a complex sugar consisting only 2 residues of exose sugars. 2 residues of exose sugars, which are already condensed together. They are already condensed together. You know, we have discussed condensation before. Combination with in the absence of water molecule. Now let's look at this. For example, you have a C6, H12O6. This is an exose. Combining with another C6, H12O6. This is another exose. Now, in the forward reaction, when water molecule is added, combination, minus water molecule is gone, and here you have plus H2O. So you should know that this one is condensation, while this one is hydrolysis. So we want to combine the two together. 6 plus 6, C12. H12 plus 12, H24. 6 plus 6, 12 oxygen. But if you want to eliminate water molecule now, H2, remove 2 hydrogen from 24, you are left with 22. And remove 1 oxygen from 12, you are left with 11. This is a disaccharide. So that's why I said disaccharide is a complex sugar that is formed when 2 exoses, 2 simple sugars, condense together. That is, they combine with the elimination of water molecule. So that's to tell you from here that the general molecular formula of disaccharide is what? C12, H22O11, like as you have seen. Then let's look at common examples. Common examples of disaccharide are: 1, you have maltose, which is also known as malt sugar. Malt sugar. Then you have sucrose, which is also known as cane sugar. Cane sugar, because you get it from sugar cane, or you call it table sugar. Then we have lactose, got it from milk, which is also known as milk sugar. So this 2024 NECO practical that they did, lactose, they represented milk as specimen D. So the sugar it contains is lactose. Then the next one to talk about, we have what we call trehalose. Trehalose. Then we have cellulose. cellobiose. We have dextrins, dextrin, and so on and so forth. But the one that is common to secondary school is these three: maltose, sucrose, and what? Lactose. Now let's look at something here. Let's look at this table. Serial number. Okay. Disaccharide. Name of disaccharide. Then products of hydrolysis. Product of hydrolysis. Okay. Now, number one, we have maltose. Product of hydrolysis means when you digest it, what are the two simple sugars that will be produced? Maltose, glucose plus glucose. Number two, sucrose. Is got it now. You have glucose plus fructose. Then number three, we have lactose. Lactose, when you hydrolyze, you get glucose plus galactose. Then number four, you have trehalose. Trehalose contains also glucose plus glucose, just like this, but in different linkage. We are going to look at that later. Number five, you have cellobiose. Cellobiose. Cellobiose is from cellulose. You have also glucose and glucose. Then another one is what? Dextrin. The same thing, glucose plus glucose. Then this one, glucose and glucose, why are they not the same thing? What makes them different? What made them have different names? Yes, we will look at it now. We'll look at why they have different names. Why do they have different names? And if they have the same component of exosis, why would they not have different names? Okay, let's look at the case of maltose. Maltose. Now, maltose consists of two glucose residues. Now condensed by alpha 1 to 4 linkage. Yes, this is what we want to know now. Alpha 1 to 4 linkage, what does it mean? Now I want to bring these two spaces down. Now, look at what we are saying here. This is the first glucose. If you don't forget how to draw glucose, we have done that. Pyranose of glucose. Okay, let me use the bond line notation. Hydrogen is here. So, I have OH, I have H, OH, H, then I have, H, OH. And I have OH and H. So then, this is, if it is alpha, A should be down, OH should be up. Plus another one like this, but 1 to 4. Another one is like this, CH2OH, CH2OH, okay? Another one like then here you have OH and H. Then we have OH and H. Look at these two. This is glucose. This is another glucose, which you can also call, this is, or you call this one is alpha D glucopyranose. Why this one is also what? Alpha D glucopyranose. Now, let's see what happened here. Now, in the forward reaction now, we want to eliminate water molecule. In the backward we have plus water molecule. In elimination, that process is called condensation. Then in combination. So here, this is hydrolysis, digestion. Hydrolysis. When you want to break from the giant molecule back to the smaller molecules. Now let's look at one thing again. So let's redraw what we have here before. CH to OH. Then we have something like this. Now, you see I have OH and H. Okay, the second one now. I have CH to OH. I have H. Now, what do I want to do? I want to eliminate water molecule. And water molecule contains H2O. So what will I do? I can remove this OH and remove one hydrogen from here. That's H2O. If that one is gone, I will only add this oxygen. So that means this one is, I will now put that the remaining oxygen, this oxygen at the center. They now make up this bond to join it like this. This linkage is alpha 1 to 4. What do I mean by 1? This is carbon number 1, carbon number 2, carbon number 3, carbon number 4, number 5, and carbon number 6. This one is carbon number 1, 2, 3, 4, 5, and 6. So the linkage is between the OH group of carbon number 1 of this glucose and the OH group of carbon number 4 of this. This one is for this number 1 carbon here. This 4 is for number 4 carbon here. That's what you have. And this is, you either call it, the biochemical name is what? Is alpha D glucopyranosyl, then alpha 1 to 4, that is the linkage. Then you now have another alpha D glucopyranoside. You end it with side because this is the end. So this is same thing as what? As maltose. Maltose. Please study it because I want to remove it to talk about another one, which is sucrose. So can you see? This is disaccharide now. So that is that. Now let's now look at the second one. Okay. Now let's look at sucrose. Sucrose now. So sucrose, let me start from here. Sucrose. This is a disaccharide consisting of glucose residue condensed with a fructose molecule. Now in beta 1 to 2 linkage. What do I mean? So now this one is also known as, okay, I will try to write it there. So in sucrose now, we have glucose. Let's draw our glucose first. CH2OH. You have H, something like this. H, OH, OH, H. Then we have OH and H. So if it is alpha, okay, beta now. Beta H is up, OH is down. Now this is glucose. This is beta D. Glucopyranose. Pyranose. Now let's look at fructose. We have CH2, okay, OH, okay, OH, alright. Now this is beta D fructofuranose. Furanose having pentagon shape. Now, if we join them together, first, as we are combining them, we are eliminating water molecule. Then here, as we break it down, we have plus H2O. Now, let's withdraw what we have here. Now, then this Ca2OH now, condensation wants to happen again. What are we going to do? We want to eliminate water molecule. This one, this OH will go with what? We go with this hydrogen. Well, this oxygen will now come to the center. So we have, so this thing is going now. You have oxygen here. So now this is carbon number 1, carbon number 2, carbon number 3, number 4, 5, and 6. And this one is carbon number 1, carbon number 2, carbon number 3, carbon number 4, 5, and 6. So the linkage now is what? Beta. Beta in the sense that OH is up. Number 1 of glucose, 1 to what? 2 of fructose. Now this bond, this diester bond is called O-glycosidic bond. We call it O-glycosidic bond. So take note of that. This bond. Okay. So that is that. So what I have here now is what? Is beta D glucopyranosyl. Then beta 1 to 2. Then I have beta D fructofuranoside, which is also known as what? Sucrose. So that's what we have there. So we are going forward now. Let's look at lactose. Yes, can I take it away? Yes. I still need this glucose. Now, don't forget alpha D glucopyranose. Now, lactose contains glucose, which is this one. Then galactose. So the structure of galactose now is this: CH2OH. Okay, can see the difference. Okay, now, okay, this OH, H, then this H, OH, this okay, OH, and this is what? This H, OH. So, you know, if you don't forget, this number 1, number 2, okay, number 3, they only differ at, when we look at anomalism that time, they differ at carbon number 4. Carbon number 4, okay, if they differ at carbon number 4, it will still be H, OH. In epimerism, we have done that in epimerism. Number 1 is correct, 2 is correct, 3 is also correct. Then where they are different now is here. Instead of having, you now have H here and you have OH here. So this is what you have here is alpha D galactopyranose. So if I condense them together, so minus H2O plus H2O. So then what do I have? I'm going to have CH2OH, this, then I have OH, I have H, okay, then I have H, OH, I have OH, H, then I have H, OH. So then the other one, I have CH2OH, then I have H, okay, so I still have OH, H, then I have H, OH, I have OH, H, then I have OH, okay, I have H and OH. So I want to condense them. So what will I do? I will have to remove, so I need this OH to go and this hydrogen to go. So I will now have a central oxygen here. So this one goes, then I can curve this one here and curve this one here. So the linkage is alpha 1 to 4. Alpha 1 to 4. But this is glucose, this is galactose. So what I have here is alpha D glucopyranosyl, then alpha 1 to 4, alpha D galactopyranose, which is also what? Which is a lactose, which is gotten from milk. Then trehalose. Now, what is trehalose? Trehalose. Now, trehalose. Trehalose is a disaccharide consisting of 2 glucose residues in alpha 1 to 1 linkage. In this one, what makes it different from maltose? The two glucose will face each other. One carbon of this one and the other one carbon of the other one. So let's look at that here. Now, this one glucose molecule, OH, combining with another one, but this one will now turn like this now. Then this oxygen will come to this side. So my CHOH will now go there. Then I have what? OH here, H here. So I have my H, OH, I have my OH and H. So then what happens if it is alpha, OH is up, hydrogen is down. I have OH up, hydrogen down. So the linkage is here now. So what I have here is what? Is alpha D glucopyranose. Just like I also have alpha D glucopyranose. Now, so if I must eliminate water here, and here I must add water here, this, so then what will I have? Let me have this again, CH2OH. Okay, so I have OH here and H here. So the other one now, so I still have OH and H. H, OH, OH, H. Then I have OH, H. Then I have my CH2OH here. Okay, so now what do I want to do? I want to eliminate OH and one hydrogen from here. So I will centralize it, remove all these two, put oxygen here, then come here. So water molecule has gone, and this linkage is what? 1 to 1. That is carbon number 1 of this one and carbon number 1 of this one. So what I have here is alpha D glucopyranosyl. Then I have alpha 1 to 1, alpha D glucopyranoside, which is now what? Trehalose. Trehalose. Then look at that. Let's look at cellobiose. 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 Now, cellobiose is obtained from the hydrolysis of cellulose, and it consists of two residues of glucose, but now in beta 1 to 4 linkage. Beta. The other one glucose will stand upright, the second one will turn upside down. Let's look at that. This is the second one now. I want to turn it upside down. I still have my OH here, but it will face the other side. So turning it upside down will make me have something like this. So that my CH2OH should now be here. That used to be here now, and H should be inside. This will now be H, OH. Look at it, I've turned it upside down. Then I have OH, H. And if I turn it upside down, OH should now be down, and H should be here. And if it is alpha, OH should now be here, H should be here. So So here now, this minus H2O plus H2O. So let's look at CH2OH. Then I have this. I have H, OH. I have OH, H. I have OH, H. Then I still have OH up, H down. So the other one, I have H, OH. Don't forget what we have here. I have oxygen here. Okay, and I have CH2OH here. So I have H. Here I have H, OH. I have OH and H. And here I have H and OH. So what do I want to do? I will take this OH and take what? This hydrogen. Then this oxygen will not be centralized. So I remove these two things. I have something like this. So this linkage is what? Is beta 1 to 4. Beta. The other glucose will be turned. So what I have here is alpha D glucopyranose. Now alpha 1 to 4, then I have beta D glucopyranose, which is now what? Cellubiose. So lastly, we'll look at dextrins. Dextrin. Dextrin is obtained from the hydrolysis of starch. When you put starch in your clothes and you iron it, it's dextrins that make that your clothes to be stiff. It consists of two residues of glucose, but in what? In alpha 1 to 6 linkage. You can see the linkage is what is making them different. What do I mean by that? Okay. Now, this is alpha. Plus another glucose. Standing upright. Then here I have OH. So minus H2O plus H2O. So let's draw the first glucose, CH2OH. So I have H, OH. Let me have OH here and H up. So that's beta. So I have OH and H. Then I have OH and H. So now let me now have another CH2OH here. So the linkage now is between carbon number 1 of this and 6 of this. So this OH will go. So I remove this OH, then in between them, I extend this and I have this. So what I have there, so this is what linkage is this? 1 to 6 linkage. So what I have here is what now? Dextrin. So you can see we have done a good job. We have come to the end of some of the parts, part 1 Oligosaccharide. In the next video you are going to watch, we want to look at some other things, some biology of it, where we are going to talk about tests for complex reducing sugar, which they would have tested for in NECO 2024, but they didn't do that. So, and I hope you understand and you enjoy the class. So, please don't forget to subscribe, to share and like this video. And don't forget, those of you that are in Sapler Road, our physical lectures for post-UME, for JAM, for WIPE, NECO, nursing, entrance have started already. And God is helping us to do a great work here. We have good men. When I say good teachers, you should know what I'm talking about. So they are here, and there is 24 hours power. See you next time. God bless you. I remember my humble self, Afe Ademola Johnson. God bless you. Bye. Thank you.